Hello everyone, welcome to my YouTube channel. My name is Sheetal Patel and today in this tutorial we will discuss about visualization of basic concepts of set theory and their common problems. So let's start. As you can see, I created a set S1 which has 60 elements in it, and if we print it using the print S1, it will show all the elements of our set S1. As you can see, I created a set using the set function. We create this set using another method, that is, we simply write curly braces in place of set. Here I close the curly braces and again run it. It will run successfully, and if we again print, it will give us the same output. So there are two ways to create a set. One is the set function and another is the curly braces with the element. Now if we remove all these elements from the set and create an empty set and run this and again run this print, it will show an empty set. If we write it as S1 is equals to curly braces, then it will create an empty dictionary. But if we want to create an empty set, we write S1 is equals to set with no argument and run this and an empty set is created. Now we write our previous set as it is with an 60 element set and run it again. Okay, all the elements are shown. Now suppose we have some duplicate elements in our set, that is 4, 5, 8, and 12. Now again run this. So we have duplicate elements in our set, but as you can see, if we print our set, it displays all the distinct element of set. Duplicate elements are not displayed. Now we perform some basic operations on set S1. The first is, suppose we want to add an element in our existing set S1. For this, we write S1 dot add. Suppose we want to add 61 and run this. It will run successfully. Now we print all the elements of S1. As you can see, 61 is added in S1 successfully. But what if we want to add more than one element in our set? Then we use update function. We write S1 dot update Suppose we want to add 3 elements, 62, 63 and 64. And run this. Now we print all the elements of S1 and 62, 63 and 64 are added in our set S1. We can also add an element of an existing set to another set using the same function. First, we create a set S2 with 3 elements, suppose 65, 66 and 67. Run this and then write an update command again, s1 dot update suppose we also want to add 68, 69 and 70 and all the elements of set S2. Now we run this. It will run successfully and simply print it S1. As you can see, all the elements are added in our set S1. The next function is remove. If we want to remove an element, we use a remove function. That is, we write s1 dot remove. Suppose we want to remove 70, then run it. It will run print s1. As you can see, 70 is removed from S1. Now again, if we want, suppose we want to remove 71. Run it. It will show an key error because in our set 71 doesn't exist. But if we do the same thing using discard command, s1 dot discard 71 and run this, it doesn't show any error. So it is the basic difference between a discard and remove function. Till now we just see some basic concepts of set. Now we perform some common operations on set. For this we create 3 sets, S1, S2 and S3. S1 which has elements 1, 2 and 3. Another set is S2 which has 2, 3 and 4. And the third one is S3 which has 3, 4 and 5. And run this, it will run successfully. Now we perform an intersection operation between these sets. Intersection means the element which are common to both the sets. So for this we write S4 equals to S1 dot intersection S2. Run and print. It will give the output those elements which are common to both the sets S1 and S2. Now we print S4. It gives the output 2 and 3 as the common elements in S1 and S2. Now if we want to find out the intersection between all the three sets, so for this we write S4 equals to S1 dot intersection S2 comma S3 and print S4. It will give the 3 as output because the 3 is the common element in all the three sets. The next operation is difference, which means all the elements which are in S1 but not in S2. That means which are exist in one set but not in another. So we find the difference between set S1 and S2 by writing S4 is equals to S1 dot difference S2 and print S4. Now run. So the 1 is the only element which is in set S1 but not in set S2. We also write here S2 dot difference S1 and again run. It will give 4 as output because the 4 is the only element which is in S2 but not in S1. Now if we want to all the elements which are in set S2 but not in either set S1 or S3, then we write S4 equals to S2 dot difference S1 comma S3. That means all the elements of set 2 are also present in either set S1 or S3. We also write here S1 comma S2 and run. Then it will show an empty set. The next operation is symmetric difference, which means the elements which are distinct to both the sets. For this we write S4 equals to S1 dot symmetric underscore difference S2. Now we run this and print S4. It will give 1 and 4 as output because 1 and 4 are the distinct elements in set S1 and S2. Now we perform the operation on lists. So in next step we create a list with duplicate elements, which is li equals to 1, 2, 3, and again the same element are repeated. So a list Li is created. For removing these duplicate elements from the list Li, we create another list L2. Suppose we give the name it as L1 and the second is L2. Using set set li and print it. Then it remove the duplicacy of list L1. Similarly, to perform some other operations, we create the three lists which are employees, gym members and developers. Now we perform some operations on this list. Now suppose we want all the members of the list which are developers as well as gym members. Then we write result equals to set gym member dot intersection developers and run print result. It will print April and Corey because these two persons are developers as well as gym members. Now we want those members which are neither a gym member nor a developer. Then we write result equals to set employee dot difference gym members developers. It is capital E. Now run this. Sorry, it's employees. Now we run. Oh, yeah. It is spelling mistake. Now it is correct and it will run successfully. We print so Jean is the only person which is not a gym member, not a developer. He is just an employee. And at last we perform the member test, which means a particular member exists in a set or not, by writing if Suppose Core in developers. If Core is in developer, then we print found. It will run successfully. Okay, this is all about basic concepts of set theory. If you like it, then please share it and like it. Thanks for watching.